We have some intuition for why the variance of the sample mean should be less than the variance in the original population. But let's derive exactly why that variance should be sigma squared over n. So what we're interested in is the variance of y bar. Remember that y bar is equal to the sum of all the values in our data set divided by n. But remember also that variance is on a squared scale. The variance is the average of the squared distances between the data points and their mean. So if I multiply the quantity that I'm taking the variance of by some number, then when this number comes out of the variance, it's going to be squared. In other words, if the variance of women's heights is 4, then the variance of 3 times women's heights, in other words, I take each woman's height and multiply it by 3. If I take the variance of that, it'll be 4 times 9 as opposed to 4 times 3 because that 3 was squared as part of the calculation. Here, though, instead of multiplying whatever I'm taking the variance of by 3, I'm multiplying by 1 over n. Because the variance is a squared quantity, we get 1 over n squared on the outside. So far, the variance of y bar is equal to 1 over n squared times the variance of the sum of all of our data points. Because we're sampling independently, and only because we're sampling independently, it turns out to be true that the variance of this sum is equal to the sum of the variances. In other words, the variance of y1 plus y2 plus y3 plus y4 is equal to the variance of y1 plus the variance of y2 plus the variance of y3 plus the variance of y4 up to the variance of yn. We're only allowed to do this step because we're sampling independently. If the fact that one particular person is included in your data set is correlated with whether another person is included in your data set, then you can't do this. Then the variance of the sum of two quantities involves the correlation between those quantities, but that's not the case here. Okay, so we're almost done with this calculation. The variance of any particular woman's height, any particular draw from the population, is sigma squared by definition. So this quantity here is equal to 1 over n squared times sigma squared plus blah, 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 plus sigma squared, n times, in other words, this is 1 over n squared times n times sigma squared, which is equal to sigma squared divided by n, which is what we were trying to show. The variance of the sample mean is equal to the variance in the original population divided by n.